Hello friends, today we'll discuss about evolution of the databases. Okay, so evolution of databases means what? When these databases got evolved, right? So before these databases comes in, what was the situation? What was the mechanism to store the data? That we need to understand. Then when these databases got evolved, right? Okay, and you know what is a database, right? Database is nothing but it is a software. Okay, it is a mechanism to store the data basically in organized way. Okay, that we'll discuss now. Let's begin. Thank you.
Yeah. Okay. Let us cast our mind back in 1960s. Okay. What was the mechanism? What was the mechanism to store the data? To store the data. What was the mechanism? Let us cast our mind back in 1960s. What was the mechanism to store the data? I think you are aware that tape recorders, right? Tape recorders. Tape recorders, right? Okay, we will be having tape recorder like this. Okay, with some buttons like this here, and we have to insert a cassette here. Okay, so it will go like this. Okay, so it has a functionality. Cassette will be having some recordings. Okay, we can play that cassette. Okay, you can record your voice or song into the cassette. Okay, so it has a mechanism, read and write. It has mechanism, read and write. Right, so this is a cassette tape recorder. So tape recorder is one mechanism where we can read the data and we can write the data, right? But here is one challenge. Let's say we have 5 minutes long song is there. Now song is there. Okay, it is started from here and it is ending here at the something point. Okay, there is this is a song in between this, right? If I wanted to go into this particular point, okay, what I have to do? If I started from here, I have to do fast forward to reach this point. Okay, if I am here, then I have to do fast backward. Okay, so and again do some backwards and then I have to go to that particular point. So this is the some tedious job. The job is very tedious job. Retrieving the data to go to the particular point. This is one thing. Okay, so these are the tape recorders I have just discussed about. Okay, we have some other things are there. Okay, at some organization levels, how at organization level, how do people store the data? They used to store the data into paper tapes. Paper tapes. I will show you some diagrams there so you understand. Paper tapes and punching cards. Punching cards. Okay. So these two mechanisms are there. Were there that time during 1960s. During 1960s, okay, people used to store the data into paper tapes and punching cards. Okay. For storing the data, 1 MB of data. For storing 1 MB of data, you need to have 50,000 punch cards. 50,000 punch cards. Okay, so like this, you'll be having 50,000 punch cards. Okay, again, if you wanted to retrieve specific information, then we don't know in which paper tape or in which punching card that information is resides. This is again tedious. This is again tedious, right? Tedious. Okay, tedious to retrieve the data. So here at this moment the data was not organized correctly. So it was it correctly, and it was difficult to retrieve the data from out of it. Right? So far so good. So to address this issue, what is comes and I'll tell you. To address this issue, okay, let me get back screen. Address this, data. To address this data retrieval and data storing, data storing. Okay, there were couple of models comes in. One model is came from IBM, that is the hierarchical model. Hierarchical, storing the data in a structured way. And there is another model comes in, that is networking model. Okay, networking model I can say. ING. Okay, so this is a networking model. So IBM brought up their hierarchical model to store the data in a hierarchical way. Okay, IBM brought up their hierarchical model to store the data. But what is hierarchical model? Right? Okay, hierarchical model means, let me explain you how it is hierarchy. Let's say you are working for any company, right? Let's say you are working for any company and there is a CEO. In any company there is one CEO, right? Under that CEO, let me take another example here. Okay, so this diagram is not good. Let me take an example here. Okay, there is one CEO. Okay, there is one CEO. Under that you having 5 directors: director 1, director 2, JR3, JR4, and DR5. You'll be having 5 directors. Okay, and under each director you will be having 4 to 5 managers. You will be having managers, right? MGR 1, 2, 3, 4, and here is a MGR 5. That's how the company builds, right? Okay, CEO, directors, managers, and then employees, right? And in each employee, in each manager, okay, you will be having 5 to 6 employees. MP1, 2, 3, 4, and here is the EMP5. Okay, so this model, whatever model you are seeing here, this model, okay, it has a hierarchy. Okay, CEO, director, manager, employee. This is a hierarchy. Okay, so what hierarchy is? One person is having multiple relationship. Okay, now here one director is having multiple like this, and here manager is multiple relationship here. So what is this? One to many relationship. Now again, this order, if any employees, this is something I'm just telling you here, okay, want to retrieve the data in a hierarchical way, it was quite difficult for him to retrieve the data. It has to go in a very, very systematic way to retrieve the data. Okay, it has to travel. There is no access for him to access this data. Okay, it is only one-way traffic here. Okay, so there is again in this hierarchy, this is a data structure only. There are some issues were there into this hierarchical model also. To address this issue, here is a one-to-many relationship. Right? To address this issue, networking model comes in. In networking model, what is that? It is here only one-to-many relationship, right? So in networking, you know very very well, right? What is networking, right? Let's say if I have given you one product, I'm telling you that you sell this product to B and C person, two people. Whatever the price you have paid me, you will get in free of cost. That's all. I'm making two connections, and I'll be getting that product will be free of cost to me. C is also doing the same thing. He is making D and E, then he'll get that product free of cost. Like B is making also E and F, something like this. Okay, like this it is gone. It is gone like this. Okay, so this is the model. This is called as a networking model. Okay, so here in this networking model, we have a relationship many to many relationship. Okay, so this model also was not good to retrieve the data retrieval point of view, data management point of view. This model also was not good. So what happened? So this is the situation about whatever we are talking about. This is 1960. okay, starting from 1960. So that will end to 1970, right? That will end to 1970 something. So during this time, there will no good database available in the market. So far so good. Okay. So what happens that we'll discuss down the line. Okay. Just 1 second. Let me bring out the screen for you. Okay, black screen I'm choosing. Okay. Now, situation before, situation during 1960 to 1970 we have discussed, right? Okay. So no good DBs available there. Okay. When this database evolved, I'll tell you here. What happened? What happened in sorry. Okay, I told you here, right? In 1960 to 1970, no good database management there. But in 1970, what happened? The magical thing happened. What you know? I told you here, IBM is the company who IBM IBM is the company who appointed a lot of engineers and scientists to work on this data management issues. Okay, so what happened in 1970? In 1970, one of employee from the IBM, that is, his name is Agarkar. Agarkar published one paper on RDBMS. He published one paper on RDBMS. Okay, and that gives the spark. That gives the spark to whole world. That gives the spark to whole world. So there will be a data can be stored into RDBMS, that is the relational database management. Okay, so data can be stored into RDBMS means what? Data can be stored into tables, in the tables, okay, in the form of rows and columns, in the form of rows and columns, okay, and that can be accessed with the SQL. So this is the message he gave to world. Okay, he just put a seminal paper. Data can be stored into tables, in the form of tables, in the form of rows and columns, and that can be written with the SQL, structure query language. SQL means structure query language. So far so good. Okay, and I told you IBM already put lot of efforts into this data technology, and he brought up his system R in 1973, followed by Ingress. Ingress was developed in 19 okay, he brought up in 74, and Ingress was developed 1973 to 1977, and this was developed by student basically. So they got one project on this database management, and they developed in California University. California University. Okay, so this was in this database was developed during that time. Okay, now whole world have to know about this thing, RDBMS database. This one. Okay, so but did not get much attention about the customers. What happened in 1977? What happened in 1977? What magic happened? Okay, so Larry Ellison and his friends. Okay, Larry Ellison and his friends, they discussed about this RDBMS, and they founded one company, that is a SDL, Software Development Laboratories. They founded one company and developed a V1 version of this RDBMS. Okay, and in 1979 they changed their company's name to Oracle, and they developed V version, and they made this version available for customers to use it. Oracle developed this RDBMS in such a way that they provide a lot of functionality into RDBMS, and a lot of functionality into RDBMS, lot of functionality they put into RDBMS in their V2 version, and they got a very good response from the market. And in the start only, they occupied 60-70% of market in the database technology. Okay, so they capture 60-70% in the database technology. What happened? I now put a lot of efforts into this. So IBM brought up its DB2. IBM brought up its DB2 in 1983. Sybase also brought up their database in 1984. By this, Microsoft also joined in 1987. Okay, Microsoft also joined this, and in database support world in 1987. So how many players we have now here? Okay, so let me take another slide here. How the database is going, right? Now, how many players we have? Oracle DB. How many stakes? 60-70% of stakes are here from Oracle. Then we have DB2, then Sybase, then Microsoft, MS SQL. So all these players, having 30% stakes on the market. Okay. Now, so far so good. Okay, Oracle playing a leader role in the database technology, and other database players is participating like in 30% of their participation in the market basically. Now, I'll tell you here. Now, so far so good, but what happened when data started growing? Now, applications, right? So basically, how this the database structure looks like. I'll tell you here. Okay? This is the database here. Okay, you will be having application data like this here. Okay, and you will be having users here, end users. Okay, you will be having end users here like this. Okay, you will be having end users like this. Okay, so you are trying to connect to these applications, and this application is pointing to database like this. Let's say initially I have only 1000 customers. And this 1 DB, Oracle DB was sufficient to handle this load. This is situation till 1990, 80 to 90. This is situation till 80 to 90. What happens? These customers increase to 1 lakh. What happens now? This one database is not capable to handle the load basically. So this is application only, but it is accessing all the data. It is performing DML operations. Okay, delete, insert, update, select all operations, right? Okay, so when you have customers number increase here, basically, then what happens? You have only 1 DB, right? Okay, so this is the 1 DB situated on one server, basically server. Okay, now let's say current one database is supporting 1000 customers. Now I have 1 lakh customers are there. Down the line, accordingly, I'm just telling you here. Now what I have to do? I have to create another server. Okay, now what happened? So when this customer increase, then this application went to the Oracle and asking them that our clients are facing some issue, performance issue. So what Oracle also has that now earlier only we had only 1000 customers. Now it got increased to 2000, 3000, like it is to 1 lakh, and now situation is changed. Okay, so which customers are there? So they started scaling up their machine. Okay, they started scaling up their databases. Now already we had one database. Now they start to another database into another machine like this. Okay, like this. Okay. So they are adding machines on it. They keep on adding machines on it based upon the load. So what happened? 1000 customers were there here. Okay, now they wanted another 1000 customers will be distributed here, another 1000 customers will be distributed here. So load distribution concept comes in. Load distribution comes in. Okay, there are other concept comes in, like clustering the databases. Okay, let's say we have 10 machines are there, so 10 machines will be acting as only one machine, 1 DB only, right? So real application clusters comes in. Okay, so this kind of new modern databases started evolving. This kind of modern databases started evolving starting 1990. Okay, Oracle, no, I'm saying Google brought up their big table DB. Amazon brought up their DynamoDB. So how many databases we have now here? So these are the databases are evolved during this time. So how many databases we have now here? Okay, so this is how the databases got evolved. Okay, now we have Oracle. Now it also took the modern shape here, Oracle DB. Okay, you can scale it up. We have SQL DB, MS SQL, right? We have MS SQL DB. We have DB2DB. We have Sybase DB. We have Bigtable DB. That's from Google. Okay, we have DynamoDB. DB. Okay, this is how the databases evolution started. This is how the databases evolved, which is started from 1970, I can say, and till today. So now there are enhancement in technology. Early on the on-prem databases only. They are on-premises, right? Now database move to cloud now. Database move to cloud now. Okay, that we will teach, that we will learn. Okay, but that's how the evaluations of the databases happen. So I take here. So this is a tape recorder. I was telling about this tape recorder here. Okay. So tape recorder. This is a tape basically, and this is a tape, right? And here is some mechanism. Here is some mechanism which is touching to magnetic tapes from the tape recorders. Okay, and then it is reading the data, writing the data based upon the functionality what you are opting. This is a tape which is used to store the data. Okay, and this is a paper tapes basically. So you can see here, this is a stack of 60,500 punch cards is used to store 5 MB of data, right? So it is completely jobs. That's how we have discussed hierarchy models, networking model we discuss, right? So this is how hierarchy model is the networking model. Okay, so this is the Agar Fort I just told you some time back, right? Publish one from this, and then you got all this idea, right? Okay, so how this database evolution started. This is how we are here now, right? 1960 hierarchical network comes in. 1970 80s commercial object relational databases. Okay, it has ability to handle the LOBs and JSON. Distributed and NoSQL database started in 2000. Until present, we have Cloud Autonomous DB. So that's all for today. Thank you so much for watching and enjoy learning. Thank you.